Awesome. OK, hello, everyone. My name's Ciara. I'm a developer experience engineer at ThirdWeb. And I first of all like to thank everyone for being here. This session is going to focus on building upgradable smart contract accounts using the dynamic contract pattern. If anyone has any questions, I will be around at the end of this talk, so feel free to come up to me at the end. So before we dive into things, I'm briefly going to talk a little bit about ThirdWeb, what we do. So we are a one-stop shop for Web3 development. We handle everything from smart contracts, payments, infrastructure, wallets. So we're talking about a full stack solution here from your smart contract. We've got account abstraction tooling, which I'm going to talk about in a second. And we've also got easy-to-use SDKs, and that's just to name a few, much, much more. So I encourage you to visit our website and check it out. So account abstraction. There are many, many awesome talks and content out there on account abstraction, so I'm going to try and keep this super, super brief. But could I have a show of hands? Who knows what account abstraction, ERC, 4337, and all of that is? OK, like a decent amount of you. Yeah, probably like 60%. So essentially, we have two main types of Ethereum account. We have an externally owned account, or EOA, and this is the most basic form of account. You, the user, controls this account via a private key. If you lose that private key, you lose access to your account. There's no way of recovering it. And you can execute transactions, but that's pretty much it. And then the second type of account is a contract account, a smart contract account. So this account is controlled by a smart contract. It's controlled by code. So anything which you can define via code can be implemented into your account. So you can do things like batch transactions. You can recover your account. You can have multiple signers on your account. You can have admins. And you can completely control how your account behaves. Account abstraction itself is the mechanism that simplifies your interaction with the blockchain via these contract accounts. So ERC 4337, the protocol, the Ethereum Improvement Proposal itself defines it as an account abstraction proposal, which completely avoids consensus layer protocol changes, instead relying on higher level infrastructure to achieve the key goal of account abstraction. That sounds like a lot, but simply they are programmable contract accounts and can handle complex operations like sponsored transactions, like I was talking about before, batching transactions, account recovery, and much, much more. And all of this, while you, the end user, don't need to know much about it. They start with a personal wallet key, which can be any type of Ethereum account, so an EOA or a contract account itself, and give you, the user, the flexibility and control without complexity. So as I said, there's lots of amazing content out there, so feel free to come up to me at the end, and I can point you towards some resources. But I'm going to talk about, at ThirdWeb, what we have. So implementing account abstraction can be pretty difficult. Who has used account abstraction, ERC 4337? So not very many of you compared to how many people know what it is. And that's because it can be super complex. It's super fragmented. You have to have the infrastructure in place, and you have to have the smart contract, and then you have to build it into a front end. And it can be really difficult. So at ThirdWeb, we have built Smart Wallets, which is an end-to-end account abstraction tool, which allows you to build smart wallets. The account contract serves as the backbone to these smart wallets, and they are ERC 4337 compliant. They're completely customizable, but the defaults are set for you. So we have account abstraction infrastructure built in. You don't need to set up anything. All you simply need to do is pass a factory address, which is a factory contract which will issue accounts. And this is deployable via our Explore page simply by a few clicks, or you can bring your own factory contract yourself. To use our paymaster, all you need to do is pass gasless equals true, and then you need to connect your smart wallet. So this is the little code snippet. I'm going to try and keep code to a minimum because no one wants to see it all on screen all the time. But as you can see, it's super simple and streamlined. So we offer 3 different types of factory contract: simple, managed, and dynamic. And I'm going to dive into a little bit about what that means. But I first want to talk quickly about upgradeable contracts. So typically, an upgradable contract is an implementation contract plus a proxy contract. And the job of the proxy contract is to forward calls it receives onto the implementation contract via a delegate call. So this simply means that a proxy contract stores the state and always asks the implementation contract for how to mutate its state. So the dynamic contract pattern. At ThirdWeb, we have come up with ERC 7504. Shout out to Krishang, he's the amazing engineer that built all of this. And in a nutshell, the dynamic contract pattern allows smart contracts to evolve, grow, and be updated without having to redeploy your entire contract every single time, which can be expensive and irritating. So the dynamic contract pattern consists of a router smart contract. The router contract is a proxy and is always delegate calling what we are calling extensions, which are individual implementation contracts. So a router will store the map from function selector to the implementation extension where the function is implemented. So all you need to do to update the functionality of a single function is to add an extension and update that mapping to see where it's pointing to. And you'll see a diagram of that in a second because one of the contracts is using this. So this is a real-world analogy for you to understand this is I want to update my smartphone. Maybe I want a different camera, but I don't want to have to buy an entire smartphone again in order to be able to have this functionality. And that's what the dynamic contract pattern achieves for smart contracts. It's very similar to the diamond proxy pattern, but much simpler, and the API is much easier to use without complex terminology. So how does this relate to smart wallets? So like I was saying before, we offer 3 different types of factory contract to issue smart wallets, and that is simple, dynamic, and managed. And the difference lies in how these contracts are upgraded and managed. So accounts created with the simple smart wallet are non-upgradable. And with dynamic contracts, the accounts can be upgraded individually. So the owner, the admin on the individual account can upgrade their own wallet, their own account. With managed accounts, the upgrades are handled centrally via the factory. So the admin on the factory can do push upgrades to all of the child contracts, the child accounts underneath. I'll go into a little bit more about how this works now. So for dynamic contracts, dynamic accounts, as I was saying, they themselves, the account itself, is a router, and it inherits from the router contract, and it is itself, obviously, a dynamic contract. So upgrading an account simply means updating the mapping, which is stored in this function, so that the mapping of function selector to extension now points to a different extension. So you can see that the contract can then grow to arbitrary length, any length that you would like. And rather than having to redeploy the entire implementation, I can now just add or update an extension. For managed accounts, the account is also upgradable, but the main difference between these two is that that function selector to extension mapping is stored in the factory contract itself. So when that factory contract updates that mapping, all of the child contracts will now have a different implementation for whatever function is being called. So how do we actually perform these upgrades? How does this actually work in practice? I feel like this is super important to highlight because it can all sound super arbitrary. And all it is calling this function add extension with the extension struct as an argument. And this will either add it if it doesn't exist or update it if it does already exist, the function selector. So you can see that that is super simple and easy to use. And the use cases for this are innumerable. So for instance, if an exploit is found on your account, you can easily and quickly do push fixes to fix this vulnerability. You could switch out your signature scheme or change how account recovery works, for instance, with adding how many signers are needed to recover your account. So that is the lowdown on how we are revolutionizing smart contract accounts at ThirdWeb. We always aim to make blockchain interactions more efficient, intuitive, and upgradable. And thanks to the dynamic contract pattern paired with smart wallets, which is, as I said before, our account abstraction toolkit, this is super easy and simple. So if you have any questions, thoughts, skepticism, or anything at all, I would love to hear it and around to chat afterwards. And thank you very, very much.